Welcome back to NeoForge mod development tutorials. In episode 2, we talked about how to create a very simple block. This episode, we're going to talk about how to make much more advanced blocks. Now, the first concept we're going to dive into is block states. Block states are Minecraft's way of allowing blocks of a similar type to have slightly different data associated to each instance in the world. It's important to understand that from a code perspective, there is only one instance of each block type. So there is only one instance of the dirt block. If an object requires different data to be associated with different placements at spots in the world, then one of the ways to do this is through block state. Let's look at some examples of block states in vanilla Minecraft. The first one we'll look at is the log. You might already know that if you place down this block, you can rotate it in a number of directions. If we press F3 to bring up the debug menu, and look on the right-hand side, right about in the middle, we have information on the block we're looking at. This is a Minecraft oak log type, and just below that, we have the axis. Now that is representing a property within this block's block state. Logs have just one property, and it's the axis. It tells you which direction this block is facing, and subsequently how it should be rendered. Now we don't have to just use block state for rendering, it can also determine gameplay information. For example, if we look at the redstone lamp, place it down, open the F3 menu, on the right hand side we have the lit property. Now this is a Boolean property representing whether or not the redstone lamp is lit or not. If we turn it on, we'll see that the value of that changes from false to true. It also changes whether or not this block emits light. The lever itself has some interesting block state properties. Unlike the other two examples we looked at, it doesn't have just one, it actually has three properties. It has the face that it's attached to, the directionality, and whether or not it's powered. We can see these change in real time as we change the lever. If we return to our diagram, we can start to understand how these blocks are structured to enable different block states. Each block instance is going to have a block state definition associated with it, and this block state definition defines a number of properties. The common ones used, and you can create your own, but you probably won't need to since we have a good coverage with these three. Integer property, Boolean property, and enum property. What these do is allow a set number of block state variants to exist in the world, and from that we can associate different rendering, different game states, and different logic to each of the different variants. Now I'll show you a couple examples of how you can implement different block states. The first block we're going to make is very simple with just one property, and that being a Boolean property. Very similar to a redstone lamp, we want something that changes texture depending on the on or off state of this property. I've gone ahead and prepared two textures for this, an on state and an off state. If you want to make your own textures, I recommend using Paint.net on Windows because it's a free editing software and it has a lot of capabilities. It's great for pixel art, but what you should know is that Minecraft's textures must always be square and the size should always be some power of 2. So 16 by 16, 32 by 32, and onwards. I've saved our textures inside of our resources folder under textures and block. What we need to do to start off with is create a new class to represent this block with custom data. To do so, we'll make a new package called block inside of our main mod directory. Now we'll make a new class for our block. I'm going to call this toggler. Make sure that your class extends Minecraft's base block class. And we'll create the default constructor. It takes one parameter, and that's properties. Now there's two methods we want to override in order to add our block state definition. You don't need to know these off the top of your head. If you get lost, you can always look up Minecraft's default implementation. A good place to look would be redstone lamp, because that's very similar to what we'll be creating. The two we're interested in are get state for placement and create block state definition. Back in our own class, we'll add an override and create our create block state definition. Here, we're going to add any properties that we want to belong to our toggler block. Minecraft has a number of built-in properties, so we don't need to create a new one. If we look at what's available to us in the Blockstate Properties class from Minecraft, there are a number. Lit is what we're going to go for. The other method we need is getDefaultState for placement. And what this method does is when a block is placed, it provides some context and we're able to return the specific block state that we want to be placed into the world. In our case, we always want to place the false state. We'll get the default block state and set the value of lit to false. The last thing we need to do is register the block state. We'll call the register default state method in our constructor and pass it some block state. Now that we have our block class set up, we need to register a block and an item for this. Inside of our blocks class, we can copy over the one we already have, rename this to toggler. Make sure we change this block instantiation to reference our new class and the ID. We'll do the same thing inside of our items class. Now we need to generate the rendering data for our new block and item. If you don't already have your model provider class created, please look at episode 3 where I teach you how to set up your data generation. In our model provider class, we're going to start by generating two models, one for the off state and one for the on state of the block. We can use Minecraft's model templates to make this easier. We use the cube all template because we're interested in applying one texture to all 6 faces of a standard cube. The create method will take 3 arguments. The first is the block. The second is a texture mapping, which tells it which textures to use for which sides. And the third is the output of our block model. For now, we'll put a placeholder texture mapping. And the output can be retrieved from the block model generators. Now let's create our texture mapping. We'll call it texture mapping off, and we'll create a texture mapping for a cube. We're going to pass it a resource location that defines the location of our texture. We know it's inside of our mods folder, and the specific location is block toggler off. Now we can duplicate these 2 lines to create the on texture mapping and model. Lastly, we need to link these 2 models to the right block state variants. We're going to declare a block state generator. And we'll use the multivariant generator, which does as it sounds. It allows us to assign multiple variants to specific models. Again, we reference our block. And we can use some nice helper methods provided to us by Minecraft's utilities. The create Boolean model dispatch takes 3 arguments. The first is the Boolean property that we want to target. In our case, it's going to be the lit property that we defined within our class earlier. And the next 2 arguments are the 2 model locations corresponding to the on and off state respectively. Now we can pass our block state generator to the output so it actually generates for our specific block. And that's it for the block models. We now need to define the item model. This is fairly trivial. First, we create an unbaked item model. We can use a utility function to easily do this and reference our block model. Then we register this model to our specific item. Now we can go ahead and generate our model data and see what happens. We got an error caused by illegal state exception, duplicate model definition for toggler. The issue here is that when we created our cube all models in these two lines, what we need to do is make sure that they have a distinct name instead of both trying to generate for the toggler. We'll replace this block reference with a new resource location with the desired name of our outputted model. I'm going to call this toggler off. We can repeat the same thing for the other model. And now we can rerun our client data. Our generation has succeeded, and now we have generated 4 new files. Let's have a look at what they are. We generated a block state for the toggler, and here you can have a good understanding of how this works beneath the surface. We generate a variant for each Boolean property state corresponding to a certain model. We can look at these two models we generated and see that they are a cube all with a specific texture. Lastly, our client item is parented to the toggler off block model. Now we have our new block available to place. If we place it in the world, we get the default off texture as we specified in our default place condition. Right now, we have no way of obtaining the other state in-game. What we can do is use Minecraft's built-in debug tools to access it. If you use commands to give your player a debug stick, you can use this to manipulate the block states of blocks in the world. Right-clicking will toggle through the available properties. We can see that when lit is false or true, we have 2 different models and therefore 2 different textures. Don't forget to add a name to your block in your localization file. And also don't forget to add your new block to your Creative tab. If we want to make it so we can obtain both variants of our block in the game, we can copy the code from the Redstone lamp block so that it's controllable via Redstone. These 2 methods, neighbor changed and tick, will allow us to do so. We're going to copy them straight over to our toggler block class. The only thing we need to change is make sure the block property is the right one. And now we can throw away our debug stick. Instead, use a lever. And that brings us to the end of this video. I'm going to make a part 2 where we talk about how to make even more advanced block states that are both rotatable and have an on and off state. Of course, if you like this, leave a like, and I'm happy to answer any questions in the comments. Hope you have a great day.